Right, year 13, I'm going to do a video going through the mark scheme for both of these questions I've asked you to do this week. Well, by the time I post this, it'll be last week. But I'm going to do them in two separate videos because otherwise, I'm just going to ramble on far too long and then you won't watch it properly. Anyway, so we're going to do this pendulum one. Now, I've always pronounced this bifilar, but now I'm wondering, is it bifilar? Don't know. Anyway, it just means it's a pendulum that is suspended from 2 points. So normally a pendulum is just one thing swinging. This is something that is swinging from 2 different points. So the reason I'm going through this is just because I know you're not actually doing the practicals, and that can make it even more confusing to do these, and they're tricky enough to begin with. There's a lot of information in these. Do make sure that whenever you're doing these for real and now that you do read through it, because it gives you an idea of what's going on. Okay, so this here was a meter stick, or sorry, a half meter stick. And then there was another one underneath it, and they're just tied together with 2 bits of strings. Then all the pupils had to do was rotate this here so that it oscillated. So it ended up oscillating like about the 2 points. This picture here is as if you're looking down on it. So this one's the top meter stick, and then this is the bottom one, would be oscillating around like that. Okay, anyway, let's actually get started with it. Okay, so again, a lot of information. Remember, you've got 30 minutes for each of these questions. They do end up being quite tight for time, but that's more to do with drawing the graph and all that kind of stuff, not actually taking the readings. So make sure that you do read all this properly, because there's sneaky wee bits of information in there that you can hunt out. Okay. Now, whenever I'm going through this, I don't have answers written in for them all. I have like ranges of answers that will be accepted, but I'm just telling you what the marks are for. I am going to be marking these, so whenever you have them submitted, there's only 2 submitted at the minute as I'm filming this, but whenever I'm marking them, I'm going to like mark on, I do it on my phone because my iPad is so slow, but it's quite annoying. It takes a wee while for the photo to open, for me to edit it, and then it takes a wee while for it to save. So it is quite time consuming. So do have a wee bit of patience with me getting that back back to you. In the meantime, you can go through this and mark your physical copy that you have, and then sure, we'll see at the end if our marks match up. Okay, right, anyway, I need to shut up and get on with it. So the black pen here, these are the numbers that I gave you in that picture for the results, as if you had have taken or done the practical yourself. I know this one said 11.2, but whenever you work out the average, it's 11.19. It ends up not affecting anything anyway. So for all of these, I'm just going to go through what the marks are for, and then any other way that you might lose marks in this, right? So I'm just going to work my way around this way. First mark out of these 4 marks is for having more than one set of values. So for doing your repeats, I normally say repeat 3 times because it means you see any problems in it, but repeating twice is enough to give you the marks, right? And for having your heading and then your unit after a wee slash like that, they don't give you the mark if you put your unit in brackets. So if you have time for 5 oscillations, brackets S, you're going to lose that mark, even if you have all these readings here. Okay. They're quite sneaky like that, like there's lots of things to have done to get marks, and then they're like, oh, but by the way, you also lose a mark if you've done this other thing. Right, the second one is for this distance value here. These all have to be given to 1 decimal place. So even if one of them isn't to 1 decimal place, you don't get that mark. And your final value here had to be at least 36 centimeters. So Megan had commented that she thought this might have been one of the reasons for this person losing marks in these results I gave you. This one's actually fine, but remember they do take account of the range of values that you take. Because this was only a half meter rule, 38 centimeters is only 6 centimeters from either end. So that is basically using the whole apparatus. If it had been a meter rule and it was only 38 centimeters, that wouldn't have been enough. Okay, I have no idea what's going on with my lighting here and why it's changing so much. No, oh well. Right, so that's the first two. This mark is for having all your times greater than 5 seconds. So this person did not. They were not timing for over 5 seconds, so they have lost that mark. That is why I will always do 10 oscillations as opposed to 5, because no matter what we're doing, 10 oscillations generally will give you something greater than 5 seconds. This one was sneaky, I thought, because like you only realize, because as the distance increases, the time gets shorter. So you only realized that you only had, you were less than 5 seconds by the end. So I think that is a wee bit sneaky, that one. Right, so that was the third mark. Fourth mark for having all your 5 values of t correct. Okay, now be careful here, and I'm fully aware that I make this mistake all the time, and maybe having this, dear goodness, I hope I haven't, but the examiner will type in these two numbers, calculate the average, divide by 5 to get the time of one oscillation, and if you have rounded that incorrectly, you lose the mark for all numbers. So be super careful with your rounding. Okay, hopefully I have rounded correctly, because you know that is my most common mistake. This is actually the second time I'm doing this, because as I was recording this first time round, I realized I had divided this by 10 to get me this, because I'm so used to doing 10 oscillations. What an idiot. Okay, so that is the 4 marks, but then you also lose a mark if any of your time values is not to 2 decimal places. So this one here, in the picture I give you, it was only to 1 decimal place, so this person would lose the mark. So that applies to your time period, your average, and any of your original values. They all have to be to 2 decimal places. Okay. Right, so it tells you the period for this bifilar or bifilar pendulum is described by this equation here. Now just by looking at this, I can already tell logs are going to be involved here. Logs generally are involved in one of the questions in this paper. It tells you K and B are constants. So for part B, part 1, show that a graph of log T against log D will result in a straight line graph from which values of K and B can be determined. So that is taking your original equation. Let me write it out here. So T equals KD to the power of B. And then you know that you have to get log T to be your y-axis and log of D to be your x-axis. Right? So if we take log of both sides here, you get log T equals, now remember your rules for logs, 2 things multiplied together, whenever you take logs you end up adding them. So this is going to be log of K plus, and then things with powers, the power gets multiplied in front, so B log D. Okay, that's the extent of like your knowledge of log rules and things that you need for physics. You probably need more in maths, but if you can do that from those like things I posted from that book, you're fine. So there's 2 marks for this. There's 1 mark for taking your logs and doing it properly, applying the rules properly, and then having it properly mapped to y equals mx plus c. So I would have y equals mx plus c lined up under there. I like to map like by doing that. You all know that by now. It's also okay to map just with wee arrows, but see with things like this, whenever they're multiplied together, that's why I like doing my wee loops. Okay, so that's what the 2 marks are for there. State how B may be determined from this graph. Well, look, the B is equal to the gradient, and you can't just write down gradient. They'll not give you the mark if you just put gradient. You have to say B equals gradient. I know that seems extreme, but generally people do well in these, so they have to be fussy. Now, C, to draw the graph, it's necessary to calculate additional quantities from your results, because look, we've just said this is the information for our graph, but we don't have any of this yet. We just have the D and T value. We don't have logs of those. So it's necessary to calculate additional quantities. Complete the final 2 blank columns in table 1.1 with appropriate headings and values recorded to 2 decimal places. Now, it says 2 decimal places there, so if it tells you that, don't worry about any rules you've learnt about decimal places and things. And it is shocking. So remember, it's shocking the number of pupils that specifically whenever it tells you 2 decimal places that they ignore it. Now, there's 4 marks for this. The first mark is for your 2 headings. Be super careful with this. In my experience, loads of people lose this mark. So see, whenever you're putting your heading in, log of t in seconds, it's log of t doesn't have a unit, but you need to specify what t is in before you're taking logs of it there, right? So log of t in seconds in brackets, and then log of d in centimeters, right? If you had changed that to meters, as long as your numbers matched up with your unit, that is absolutely fine. Also, any error carried forward would be applied to these marks here. So say, like me, you had divided by 10 instead of 5 here. I know I have fixed it now, but say you divided by 10 because you're so used to doing 10 oscillations. You'll have lost the mark for getting your t values correct. But from here on in, you'll get the error carried forward marks. Okay, so they are good about that. So the first mark is for having log of t in seconds and log of d in centimeters. There's one for your log d values, there's one for your log t values, and then there's one for everything being to 2 decimal places. So that one's quite clear to see. And again, I hope I haven't made this mistake, but if any, so there's one mark for log d values, these ones. If any one of these is just rounded incorrectly, you lose that mark. Same here, there's one mark for your log t values. If any one of those is rounded incorrectly, you lose that mark. And the examiner does sit with a calculator and type it in. Okay, D, plotting the graph. There's 5 marks for it. Okay, I'm going to try and get my graph and this little thingy-mabobber in the screen at the one time. So, give me a second. Okay, I think I can just about get it in here. But there's 5 marks for this. Now, in this photocopy that I have, this is just my mark scheme that I have been using all year. The graph paper didn't photocopy, but I took a bit of normal graph paper and changed it and just like marked off so that the squares matched however many squares they had given you in the exam paper, because quite often in these the scales on the graph end up being quite awkward. And I have not checked mine. I do not know if my graph is going to get me full marks here. Let's discover together. So 5 marks. There is 1 mark for your X scale and 1 mark for your Y scale. And by that we mean a regular scale and that your points take up at least half of the space available. Now here is what the examiner is going to do. So this is the maximum space I have available. They will measure from, I think with mine it's fairly obvious I am taking up at least half the space, but if they are questioning it, they will measure from 1 point to your final point. So for me that is 8.5 centimeters. The maximum space I had available there is 14. So, oh, I can't even count. Oh yeah, it's nearly 14. So it wouldn't be possible, so sorry, that is over half of the space that I have, so that's fine. And then they'll do the same for the y-axis if they're questioning it again. It's fairly obvious that mine's taken up more than half the space. So check that for yours. Sometimes it's really borderline. The scale I ended up going with on my y-axis was every big square being worth 0.05. I have a feeling that 0.04 does work for this as well, but I hate scales like that. They're allowed, but I just don't like them. Right? I think lots of people did do that though. And then a scale of 0.1 for every big square along the bottom was what I went for. Oh, I did want to say as well, see here, I know technically my x-axis should be here because this is 0, but they'll not take marks off you if you have it marked on down here, even if this is going into the negatives, like this one did. Okay, so that's the first 2 marks for your scales. Oh, if you've a broken axis, what I've done here is fine. So I've obviously started at 1.1, but, or if I'd started at like 1.1 here and done the wee squiggly line, that's also fine. But if I put 0 here and then 1.1 here and then 1.2 here, I would lose a scale mark, because I'm saying that that whole thing would be worth 1.1 and then this one's worth 0.1. So be super careful with that, right? If you're doing a broken axis, I just don't put 0 in at all, and then you're fine. Right, let's see. 2 marks for your points, and again the examiner will check them. You're allowed to be one wee tiny square out, and they take 1 off for every point that's wrong. And then 1 for your best fit line. I'm not the proudest of my best fit line here. I think it would still get the marks because I have 2 off both sides. But it's not going through many points, which makes me think, did I plot this incorrectly? Hopefully not. Also, -1 if any of your labels are missing. So if you haven't labelled your axes, you're losing. Even if you got all these 5 things right, you're going to lose a mark for that. Right, last little bit then is part E. Use your graph to determine the values of the constant b. So we had set up here that b is the gradient. So to figure out b, you would need to figure out the gradient on your graph. And there's a mark for using a large triangle. I feel like I'm a broken record with this. Don't just pick like this point and this point and figure out the gradient from that. That's far too close together. Remember, the rule is that either your vertical or your horizontal has to be at least 5 centimeters. Don't necessarily pick points. Like if I had picked this point here, because it's not on my line of best fit, I would lose a mark. So don't try and pick points from your table. Pick points from your graph, like nice-ish ones. So that there I would maybe pick because it's a nice point. I don't even know if you'll be able to see that. And let's see, that one there. Right, so where they're going exactly through the grid lines on your graph paper, that's what makes them a nice point. Also, keep the examiner on your side, draw the lines in, keep them happy, right? So, large triangle, correct values read correctly, and from the best fit line, not from your points. Second mark is for carrying out this calculation properly. So 1 mark for your values and all that, 1 mark for actually calculating it right. Then there's a quality mark, so this is where they're really testing your skills on the practical, if you got dodgy results or not. So your B value had to be somewhere between 0.9 and 1.1, and because it's a negative gradient, there's 1 mark for having it as a negative. Right, so from minus 0.9 to minus 1.1. I think that is it. You can't see that other little comment I have there, but if in B part 2, which was this one, you had said that B was equal to the intercept, the maximum number of marks that you could have got here was 2, right? I think that's it for that. I think that is long enough. Thank you for listening. Hopefully you got on okay. See you in the next one. Bye.